Here's a momentum problem. I don't know if you could tell, but I made this one up. So the idea is, suppose that I'm a human, because I am, and I have a tennis ball. I have a bunch of tennis balls that I actually don't have to carry. They're just right next to me. And I take these tennis balls and I throw them down as fast as I can. And I throw them so fast, faster than any human could, with a speed of 200 meters per second. So how fast would I have to throw these balls down? How often would I have to throw these balls down so that the thrust of me throwing the balls down would allow me to hover? It'd be like a tennis ball rocket, right? And yes, this could be tennis balls. This could be air for some type of quadcopter personal hovercraft or rocket jets or water. Have you seen those water jetpack things that hover? Any of those things. I'm going to use tennis balls. I'm throwing the tennis balls down, and I know the speed, I know the mass. How many do I need to throw per second? So it kind of seems complicated at first, but maybe it's not too bad. Okay, so let's just get started. I have the mass of the person, 70 kilograms. I have the velocity of the tennis ball, 200 meters per second, with the mass of the ball of 60 grams. Okay, so what I want, I know that there's a downward gravitational force, mg, and then I'm going to have an upward force from the ball. I use lowercase b. The force that the ball exerts on me is equal and opposite to the force I exert on the ball. So let's just throw a ball down. I'm going to say V1, I'm going to use just the y direction. V1 is 0, V2 is 200 meters per second, like that. Okay, so there's V2, V1 is 0, and I don't know the change in time. I don't know delta t, okay? But I can write the momentum principle let's call this FBY is going to be delta P ball delta T, where P ball is the momentum of the ball. So I know the momentum of the change momentum of the ball. It's going from 0 to 200 in the negative direction. So that's why the ball is going to push up on me in the positive direction. Okay, let's get to that in a second, right? Because I know delta P, and I actually know what this has to be. This has to be, in scalar version, my weight. So this is going to be the mass of the human times g. That's going to have to be this force. And it's going to be the final momentum, mass of the ball, times velocity of the ball, minus the initial momentum, which is 0 over delta t. So the only thing I don't know there is delta t. Let's solve for delta t. How long would it take me to throw that ball so that I have a force that's equal, average force, this is the average force, equal to my weight? Okay, so let's erase this. I kind of organized poorly. So delta t is going to be mass of the ball, velocity of the ball, divided by the mass of the human times g, and I can plug in my values. 60 grams, I have to convert that to kilograms, 0.06 times 200 divided by my mass. I said it's not me, I'm not going to actually be, I might do it. 70 times 9.8. Okay, let's calculate that time interval. Calculator on. 0.06, enter. 200 times 70 divided by 9.8 divided by. I get a delta t of 0.0175 seconds. Now the question is, how many balls per second would I have to throw down? Well, if that's the time per ball, how many balls would just be 1 over that, right? So let's say, what should we call this? F ball, the ball frequency. It's the number of balls divided by the time interval. So let's do a time interval of 0.015 seconds, and n is 1, and this will give us the frequency, and then we can say, put that as 1. Okay, so this frequency is going to be equal to my space management for today, 1 over 0.0175. I can just take 1 over that. There is a 1 over button right there. And I get 57.2. And that's going to be balls per second. So that's how fast I would have to throw the balls down. Pew, 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 pew. Okay. And if I could throw it that fast and that many, I could hover. Of course, there is difficulty with this problem because the question says, suppose I had 100 balls. I have 100 balls that I can throw. How long would I be able to stay up? Well, if I'm throwing 57 balls per second, it's going to be, less than 2 seconds. Let's just say that. And even then, 100 balls wouldn't be too bad. It'd be 6 kilograms. So I'd have to add 6 up here. But you can imagine if you want to hover for a longer amount of time, you're going to need more and more and more balls. Now, I do want to just point out that the nice thing about like a helicopter or a drone is that they do the same thing. They throw air down and they don't have to carry the air with them because the air is already there. They're just taking air up here and throwing air down there. But other than that, it's a very similar idea. I can show you the calculation for hovering helicopters. I probably will at some point just because I love it. But that's that problem. I made it up. It's not that hard. It's kind of hard to frame and to get in the right set. But after that, it's not. It's just momentum principle. And it seems like it wouldn't work, but it works.